I'm Carl Anthony, and welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information to connect engineers, scientists, and many other automotive industry experts across the globe. Today, we're joined by one such expert who is a longtime member of the AutoSens family. Looking forward to having him back today, Matt Daley, Technical Director at rFpro. And Matt, welcome back to AutoSens. Good to see you again.
Thank you very much, Carl. It doesn't feel that long since Detroit.
It really doesn't. It really doesn't. It was good to see you in person. Good to get caught up. One of the things we talked about in Detroit is how you have leveraged all of your previous automotive experience to provide now some really innovative solutions for the market. So let's start there, Matt. Tell us about some of the solutions that you offer and give our viewers an overview of rFpro.
Yeah, sure. Thanks, Carl. So, I mean, we've been around since 2007 working in the automotive industry. And we've always had a key focus on our three main aims. That's always been, how do we model the real world? How do we then let our customers interact with that world? And then how do we let them scale their testing massively? So for the first part of our existence, that was all about vehicle dynamics testing, control system testing, driver in the loop and hardware in the loop testing. And really over the years, that's moved from high performance cars to general production cars, and now into the autonomous systems and the sensors and the automated drivers that are on top of those cars. So it's great to be able to leverage that same simulation technology and real focus on the real world and bring that into different applications of vehicle system development.
Right. So Matt, let's talk about the simulation environment. What are the key advantages of the simulation environment when it comes to the development and testing of ADAS and autonomous vehicle technology?
The obvious first point really there is about being able to control your tests, because anytime you're trying to do driving in the real world, you've got such huge variety and uncontrollability that's happening. Now, often people are looking for that. So you're looking for these edge cases in the real world, but they're so infrequent as well. So, you have that problem of lots and lots of boring miles that people are driving with huge test fleets in order to try and capture these very low volume edge case events. So, the first point really about simulation is it enables you to bring that control to your test and decide what it is you're going to test. And the second point is then you've got so much better data access inside your simulation. So you can really look inside your test systems and understand where are those systems being successful and where are they not being successful, and at what point in that decision-making tree have you found your fault. That's so much easier in a simulation when you've got access to all of the different pieces of data. And the third really then is the repeatability of your testing. Because if you're looking to go through and put fine resolution developments and understand that a very small change does actually make a difference, then that repeatability of your simulation and of your testing is a real key advantage to why simulation has proven to be so important in autonomous vehicle development.
Matt, you have a library now of nearly 200 locations, 200 digital models, and these locations include everything from public roads and proving grounds and test tracks. So tell us a little bit more about the digital models that rFpro has.
Sure. Again, going back to one of our key focuses, they're about real world locations. So, it's really important for us that we're providing these locations that people actually go and test in, because they are full of natural world variety. It's not things that we're trying to dream up in terms of the shape and the course of the road or the different objects or dirt patterns, cracks and paint lines on top of the road. All of this exists in nature. And for us, going and modeling the real world allows us to bring in that huge variety into our models. It's not just then that graphical information that's controlled inside the world. It's also the road surface and really the engineering detail that's going to go into the vehicle. So our models have a high definition road surface that enables vehicles to get the correct and really 1 centimeter by 1 centimeter in X and Y grid and a millimeter in Z accurate road inputs. So this really helps us to provide the right vehicle dynamics of the vehicle. So the sensors on top of that vehicle are shaking around as they would do in reality. We always say we're not designing hovercraft. We are designing real cars that are going to drive on real roads. And so simulations need to be able to provide that level of detail to the development engineers.
Right. Now, Matt, there have been some new developments with rFpro, and believe it or not, it's actually connected to your Zoom background, which is the nicest banner background I've ever seen. I've never had a Zoom background look that nice, but that background is not just a normal Zoom background. That gets into our next topic of discussion about high fidelity rendering and why that is important. So, Matt, give us your thoughts on that. rFpro expanding here, the high fidelity rendering, what solutions there are you offering the market?
It links to our previous discussion about location. So, in the world of simulation, it's all about correlation. You really need to trust your simulation if you're going to get out the value from that simulation. So not only do you need your locations to be accurate and know that you're getting the right vehicle dynamics inputs, but you need those sensors that are on your vehicle that are now looking into the world. You need those to have a very, very high degree of fidelity, because what we're trying to do is create the world's best machine learning data sets, and not do that by driving millions and millions of miles on the road, but by building synthetic machine learning data sets. And so it's all about the fidelity of the sensor simulation. Now, we can go and model things like the different silicon and how a CMOS chip works and its exposure periods and its line by line offsets for rolling shutter effects. And that's great, and that's all built in. And you can connect those then to very advanced ISP models. So you've now got a physically accurate model of the imager and the ISP to give you the camera. But unless you're feeding into that very, very accurate world simulations, you're going to be limited. So, it's a massive thing we're bringing to the market now, is very, very high fidelity, ray traced, real world, highly detailed and highly complicated driving simulations. And this builds on top of all of the work we've done previously in the real-time space, and using our rasterization engine for driver in the loop and hardware in the loop. We're re-implementing it, or just reusing all of our interfaces and technology and all of that time people have invested in making locations and tests, and just taking it to the new level and bringing that ray tracing engine in to allow us to go into these sorts of locations that are really difficult to do in real time to this level of fidelity. Right. And it's going to make a massive, massive difference to how people perceive their training data sets, and the level of correlation people are going to be able to get between the synthetic data and their real world training data.
So, Matt, how do we take all of that, everything that you just said, how do you package that and then scale it and do it multiple times over and over again? Give us your thoughts and perspective on that.
Yeah, it's a real key point, because it's not just about making a single simulation that's really high fidelity and gives you a lovely set of images for 3 minutes of driving. You've got to do that for thousands of different, first of all, varieties in this location, and then you've got to do it for thousands of different locations and different scenarios. So yeah, we're really proud to be bringing to market again now rFpro's HPC options. So for the first time, we're providing rFpro in Docker container images so that they can be built up into full vehicle systems in private networks inside HPCs, and all being orchestrated via Kubernetes systems. And so it's fantastic, really, that we're able to not just think about rFpro as it was in the past, which was all about solid installs on fixed hardware. Let people start there, let people develop their tests and prove their correlation. But then when they need to scale that, they can use all of those HPC Docker images and just start to scale their testing based off how much compute hardware they've either got on site or they've got available to them via their cloud providers as well.
Matt, I want to encourage all of our viewers to, visit your website at rFpro. A very dynamic company, a lot of depth to what you do. So in addition to everything we've been talking about, engineers and test drivers can use rFpro for other applications too, including tires and headlights and human factor studies. So again, a lot of depth to what you do, but talk about some of these other applications that engineers and test drivers use.
Sure. So, we've got a huge number of existing customers using rFpro for vehicle dynamic studies, developing chassis, developing the tires, the control systems that are going onto cars. You've only got to look at a number of the, large OEMs that have released lovely videos of their EV vehicle developments and how they're using their simulators. And, so proud to see rFpro in the background of those being shown up on such world-renowned marks.
Yes.
And then, a huge new area has been in headlight testing. So we've got such brilliant feedback from our first customers there, moving into their second year with us now, which is great, and showing how they're really able to accelerate how quickly they can prototype and test out headlight units without having to wait for nighttime and without having to wait for physical versions of these test units to come in. So the engineers are so happy because they're no longer working on social hours in the dark in very unsafe environments. And their accountants are very happy because it's massively reducing the cost of their product development.
Matt, I always enjoy our topics of conversation. Just as we wrap up here, just to kind of recap everything, I feel like every time we talk, there's always something new happening with rFpro. So give us an overview. Tell us what the next few months look like for you. What are you concentrated on most between now and the end of the year?
It's really getting our new ray tracing engine into the hands of the first users. There's been a huge investment we've made here over the past couple of years to make that as seamless as possible. So I think we're going to be one of the few simulation companies in the industry that can be able to do that at the flick of a switch. So, here you are, you've built up all of your tests, you've learned all of the system for how you do real-time testing and huge amounts of scenarios. And great, you now just flick a switch and you're generating the highest fidelity training data for your machine learning colleagues as well at the same time. So that's really the exciting part for us. There's a huge amount of investment and time and people's efforts we've put in, and it's now ready to get that into the hands of the customers.
Yeah, this is exciting, Matt. And again, for all of our viewers, want to encourage you to visit the rFpro website. Just an incredible company, a lot of depth, a lot of exciting things going on. Matt, want to, of course, thank you for your time and sharing your expertise and thought leadership. And from all of us here at AutoSens, we want to wish you the best of luck going forward. And I look forward to catching up with you down the road and doing an interview again and hearing about the latest with rFpro.
Great. Yeah, thank you, Carl. It's always fantastic to see you.
For more interviews like this, subscribe to the AutoSens YouTube channel and follow us on LinkedIn and Twitter. For more information on our world-class events and technical training, visit auto-sense.com. That's auto-sense.com. In Detroit, on behalf of AutoSens, I'm Carl Anthony.